Hi, in this tutorial I'll introduce you to MRhythmizer, a plugin made for reshuffling time, volume and spectrum characteristics of your audio. It's a great tool to manipulate samples or any recorded material. Let's look at its interface. At the very top we can see general parameters which affect the plugin's behaviour no matter what you're altering, time, volume or spectrum. Lower, we find three panels. The volume and filter relate to corresponding aspects of audio manipulation. The third one, advanced, holds controllers which define the plugin's synchronization and editing. Finally, here we find, I'd say, a core of the MRhythmizer. On the left, there are three tabs called time, volume, and filter. Each tab reveals 36 sequence selectors, which can be selected by commands from a MIDI keyboard or computer mouse. Each sequence has a graph. This is where you'll spend most of your time drawing bizarre breakpoint curves. Let's examine each controller and its influence on an input signal. The scratch sets a time offset, that is the time between pressing playback and a signal appearance at the plugin's output. To demonstrate this, I'm going to use a metronome as a guide to when playback starts. I'll start from the scratch equals 0. If I set the scratch to -2, then the output signal will be delayed on 2 beats. If the scratch is -6, then the delay will be 6 beats. You can also put any arbitrary value here, or you can move the scratch slider in time and see how it affects audio. The dry-wet controller is self-explanatory, I believe. Tempo. At the leftmost position, MRhythmizer gets locked to your digital audio workstation's DAW playback. It means the plugin will follow the playback stop commands and the tempo changes. At the rightmost position, the MRhythmizer still follows the tempo. However, it will ignore playback stop commands. That can lead to the fact that the sequences will be out of sync with the DAW. Finally, you can put any tempo value manually. In this case, MRhythmizer works by itself ignoring DAW's playback completely. The speed-up selector allows you to divide or multiply a current tempo value and thus push MRhythmizer to run faster or slower, but still stay in sync with the host program. We'll discuss the volume, filter and advanced panels later. Right now, let's get to know how the plugin reshuffles the sound characteristics. I'm going to start from the easiest to understand tab, the volume. As I mentioned before, 36 buttons on the left choose sequences. Each sequence is shown on the amplitude versus time plot. The horizontal axis at the bottom represents time expressed in beats. The vertical axis is the volume level shown in decibels. At the top, we find a default breakpoint curve, which is currently a straight line. If I click and drag it up and down, I'll change the output's level. It's totally up to you what sequence you want to draw here. To create a node, simply double-click on the breakpoint curve. To move it around, click and drag. You can easily change an interpolation from one node to another if you move this dot between them. The right-click on it opens up a pop-up window where you can change its properties. To delete the node, double-click on it again. Use mouse or a MIDI keyboard for manual switching between sequences. However, if you want to automate this process, create a MIDI track and send its output into the MRhythmizer. I've done my homework by creating sequences and a MIDI track, so here is my take on the volume modulation. First, the original. And now with MRhythmizer. As we are speaking of the volume modulation, let's pay some attention to the volume panel. Here we have three sliders: depth, attack, and release. The depth controls the strength of the effect. You can think of it as dry-wet parameter, but only for the volume modulation. Attack is responsible for how fast a signal will be muted, and the release sets the rate at which the signal will be brought back. Let's proceed to the filter tab. Here, the vertical axis represents a frequency range in which the filters work. MRhythmizer offers two types of filters: high pass and low pass. To make them work, we need to activate the filter panel. Attack and release controllers do the same job as the volume tab. Our main interest here is high and low pass sliders. They set the lowest and highest limits for the high and low pass filters accordingly. If I set them in these positions, they can't move, and no matter what sequence you create, you don't hear any effect. I can confirm it if I turn the filter panel on and off. The reason why we can't hear any modulation is because both filters are locked in their extreme positions and they don't have any room for movement. Now, if I set high-pass filters to 20 kHz, I'll make room for it to move from 20 Hz to 20 kHz. Note, the low-pass filter is still at its locked position and it doesn't move. To hear it move, I must shift its slider to 20 Hz, as well as the high-pass filter's slider. Now the low-pass filter is moving and the high-pass filter is locked. If you want both filters moving, then you need to put the sliders somewhere between their extreme positions. Now, at 100%, both filters are opened and we hear a pad sound in a full frequency range. At 0%, however, both filters come to 3.3 kHz, and thus they form rather a band-pass filter response. The time sequences are the hardest to understand, but with a bit of patience and effort, we can crack them too. I think that what happens here will be easiest to grasp if I use a reel-to-reel recorder concept. Imagine we have a record head up here and an erase head down here. A tape constantly moves from the top to the bottom. As soon as I press playback of my host program, the record head starts recording an incoming signal. When the recorder signal reaches the erase head, it will be erased. Thus, the recorded signal lives only for some period of time, 8 beats to be precise. So, what I do by the plot here is I set the position of a playback head along the tape. For example, if the plot is a straight line located at the very top, then the positions of the record and playback heads coincide. That is, audio gets played back as soon as it comes into the MRhythmizer. If I move the graph down here, I'll get a delayed playback because the recorded signal needs some time before it will reach the playback head. The real fun begins when we start shifting the playback's head position in time. This is actually what the Time tab is all about. The plot doesn't have to be stepped as I did. Moreover, you can even get more interesting effects if you use smooth interpolation from one node to another. But here is something you must keep in mind. If the playback head moves at the same speed as our virtual tape, you won't hear anything. If the playback head moves faster than the tape, you will get a reverse playback effect. So, why couldn't we hear anything during the first bar? It's because the playback head outpaced the recorded signal and it couldn't play back anything but silence. However, by the second bar, the recorded signal was already on tape, so the head had something to play back. You can use those tricks for a DJ-like effect. Just keep in mind, to manipulate audio, first MRhythmizer must have that audio recorded. Finally, let's talk about the advanced panel. The Note Off button enables the mode when MRhythmizer will go back to the sequence 1 if a performer releases a key on a MIDI keyboard. So, if you keep that sequence at its default settings, you could use it as a bypass. It is handy, especially during a live performance, when you know that MRhythmizer will play a sequence as long as you keep a corresponding key pressed. And as soon as you release it, the plugin will jump into the sequence 1. However, if you're a one-man band, then you will probably find this inappropriate. The triggering selects the way MRhythmizer responds to all triggering commands, whether it's note on, left click, or modulator. We can choose from 4 types. The default setting is immediate. In this mode, MRhythmizer switches to a new sequence as soon as you press a key on a MIDI controller or left-click on a sequence button. The immediate single shot mode is similar to the previous one with a single difference. MRhythmizer automatically goes back to the sequence 1 after the ending of a new sequence. In the next bar mode, when a new sequence is selected, MRhythmizer waits for the beginning of the next bar before switching over to it. The last mode, next bar single shot, allows you to switch to a new sequence but for 1 bar only. After that, MRhythmizer will go back to the sequence 1. The sequence length defines the number of beats in a sequence. Note that this value must be a multiple of the number of beats in your song's signature. For example, if the signature is 4/4, then you should put 4, 8, 12, 16, and so on here. If you set 5, for instance, MRhythmizer will round this value to 4 anyway to keep itself in synchronization with your song. However, if you put in 1, then the plugin has no choice and will set a sequence equal to 1 as well. The click protection helps to avoid potential clicks, which could happen as a result of MRhythmizer's sound manipulation. Set it as you like. In order for MRhythmizer to be constantly in sync with a DAW, it must apply its effects at strictly specified moments of time. The grid line selector determines how often or rarely these moments can happen. Think of it as a quantized functioning in your DAW. Well, I have described the work of each controller. The last thing I'd like to mention is sources you can use for switching between sequences. You already know about a MIDI controller. You can also use VST automation to record it. Besides, you have all the power of modulation sources that Melda Production offers you in almost every plugin. This subject deserves a dedicated tutorial. For now, I'd like to say, don't hesitate with experimentation. Try everything.